Download this code from codegive.com, link in the description below. Software pipelining tutorial. What is software pipelining? Software pipelining is an optimization technique used in compiler design to improve the throughput of instruction execution by overlapping the execution of multiple iterations of a loop. This technique helps to maximize the utilization of the CPU by allowing different stages of different iterations of a loop to be executed simultaneously. Key concepts. 1. Loop unrolling. This involves expanding the loop body to decrease the overhead of loop control and increase the opportunities for instruction-level parallelism. 2. Stage separation. Each iteration of a loop can be broken down into distinct stages. Different instructions from different iterations can be executed in parallel. 3. Instruction dependencies. Care must be taken to ensure that dependencies between instructions from different iterations do not violate the correctness of the program. 4. Initiation interval. 2. The minimum number of cycles between the start of successive iterations of the loop. It defines the schedule of the pipeline. Example. Let's take a simple example of a loop that performs some computation. We'll illustrate this with a basic C-style loop that adds two arrays. Original loop. Step 1. Analyzing dependencies. In the above loop, each iteration is independent, meaning the result of one iteration does not affect another. This independence allows us to introduce pipelining. Step 2. Software pipelining transformation. We will transform the loop to overlap the execution of multiple iterations. Here, we'll manually pipeline the loop. How it works. 1. Multiple iterations. The pipelined version processes 4 iterations of the loop simultaneously. This means that while the addition of Ci is being computed, the addition of Ci plus 1, Ci plus 2, and Ci plus 3 can also be computed. 2. Efficiency. By unrolling the loop and processing multiple iterations in parallel, we reduce the overhead of loop control and increase the efficiency of the program. 3. Final loop. After processing the main part of the array, we handle any remaining elements that couldn't fit into the unrolled loop. Performance considerations. Register pressure. Unrolling increases register usage, which can lead to spilling if there are not enough registers available. Pipeline depth. The deeper the pipeline, the more complex the dependencies become, and it can lead to stalls if not managed properly. Architecture dependent. The efficiency gain from software pipelining heavily depends on the underlying architecture and how well it can execute instructions out of order. Conclusion. Software pipelining is a powerful optimization technique that can significantly improve performance for certain types of loops. By understanding the dependencies and carefully scheduling instruction execution, you can take advantage of modern CPU architectures to achieve higher throughput. Further reading. Compiler design books, especially those focusing on optimization techniques. Research papers on instruction scheduling and pipelining strategies. CPU architecture documentation to understand how various architectures handle instruction execution and pipelining. Implementing software pipelining effectively requires a good understanding of both the algorithm and the hardware on which it runs, making it a complex but rewarding optimization technique.